Okay, it is Wednesday, May 28th, day 3, coding every day. My bedtime was supposed to be 10 p.m. today, but I haven't had dinner yet, and we need to code, so it looks like we're going to go a little bit past that. Yesterday, if you watched the video yesterday, I was up a little late, and oh my goodness, I paid for it today. I was so sleepy all throughout today. I had a meeting today at work, and my lord, I was so tired. So today we're gonna have to do medium, which isn't really great with having how little time I have, but yeah, let's two sum part 2, but the array is sorted. Okay, so last time we were doing two sum, and I was like so cooked because I started off with a a 2-pointer approach, and I believe since this array is sorted, I can do this 2-pointer. So let me read it properly this time, because last time I did not read it at all. I might not even use Figma. I know I'm supposed to like write these out, but I might just use that for like the hard questions. For the ones where I can just kind of like solve it on my own, maybe no LeetCode is needed, or sorry, no Figma is needed. Okay. Sorry, make sure they're recording. Given a one-indexed array of integer numbers that is already sorted in a non-decreasing order, find the two numbers such that they add up to a specific target number. Let these two numbers be The test generates there is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. Okay, so this right here is basically saying, hey, you could use this as a hash to solve this because it's the same problem, but you're not allowed to. So this is where no hashing is allowed. So I already solved this one yesterday, but I guess if no one hasn't saw what this is yesterday, what you'll do is, since it's already sorted for you, you'll do a greedy approach, because yesterday I was talking about greedy, and I was like, oh, yada yada yada, with the assumption that it was sorted, except it was not. But these are sorted. So what exactly do I mean? So you'll take 2 pointers, you'll put one at the front, you look at the front and one at the back, and then you're going to add them together, add the numbers together, and they will give you a sum. Now, if the sum is greater or less, that depends on what your next move is. So let's kind of do an example of this right here. Let me put this up. Okay, so our target is 9, and there's a solution here, and as we can see, it's 2 and 7. But how do we get to this point? We can use this greedy approach that if the sum of the 2 pointers is greater than the target, well, then that means the right pointer can start going left and getting smaller, because as we know, since it's sorted, the left number must be less than or equal to than the right number. Meaning, if the right pointer starts moving towards the left side, the whole sum will start to decrease. And then I can kind of point this out. We have 2 here and 15. That's where we're going to start. These combined equals 17. It's bigger than the target. Okay, so now I can say I want this right pointer to move left. So now we have 2 and 11, and now that's 13, which was smaller than before, but it's still not 9. So we want the right pointer to move left, and then now we do 2 and 7, and that is 9. And we're good. This is pretty simple. You kind of start, this is like automatically off rip is done. So left, right, hey, target, we're good. So this is kind of checking to make sure you don't have some wishy-washy base situation, because your base case should be like on the first go, it should be done, right? It should be ready. I mean, that's not even a base case. It's kind of like just a part of the sequence. Same thing with this. This should also be pretty much self-explanatory. Okay. Time to code. Let me zoom back in. Alright, so because it's sorted and it's beautiful like that, we're just going to say left pointer equals 0, right? The 0th index. Right pointer is going to equal the length of the numbers array minus 1. That's going to give you the last index. Okay, and then I'm just going to write a while statement. Technically, you don't need it. You can just kind of technically like, what is the maximum number of moves? Is it like log of n? I don't know. Honestly, while statement is the move. So while left pointer is less than right pointer, right? So this problem guarantees us that, hey, there will be a solution, of course. But that's not how it works in the real world. So it's always good to have your edge cases, just in case. Even though it won't matter here, I just kind of like writing it out. It just looks more natural and it feels natural. So while left pointer is less than right pointer, we're gonna, go ahead and check that. And then you're gonna write an if statement. So if left pointer, if numbers, leave me alone! Oh my days, yes I know, thank you, oh my goodness. If numbers of left pointer plus, I'm just gonna copy this. I wish I had autocomplete on this. Yeah, so if this is greater than the target, then that means right pointer needs to be de-incremented or make it smaller. Else if, I could just delete that. Right, else if it's less than, then left pointer plus equals 1, and then else, oops, forgot the colon. Else return, we're going to return an array that is just going to be left pointer, right pointer, and then down here we're just going to return null. Okay. No, didn't work. Is this one indexed? Okay. We're one indexing now. Let's go. That's what I'm saying. Gotta read the problems, man. I don't read the problems. I'm assuming this might have an error with the. Okay. So yeah, I was thinking it might have an error because it says you can't use the same element, but then again, this while statement will not allow the same element. So, all right, that's that. That was done. Finished that one up pretty quick. Boom. You know what? Should we try threesome? I know that one is one's a little bit tricky. Okay. Leak code, please. I don't want nothing popping up on my fucking computer. Given an integer array nums, return all the triplets. This one is actually hard. I do, or is this one hard? I don't know. I remember doing this before. I remember like sitting down having to think about it longer than I really wanted to. Honestly, because I want to be in bed. Not too late today. If this takes too long, I might just call it on that one and say we'll do it later, and then I'll do an easy instead. Given an integer array nums, return all the triplets such that such that none of them are the same element, and that they equal to 0. Okay, so this one has no target per se. The target is 0. Notice that the solution set must not contain any duplicate triplets. It can't contain any duplicates, yeah? Okay. Cool. Any sort of constraints? So, no time constraints or space constraints. Oh, that's fun. Okay, so I need to return the set of all the values. Oh, oh man. Oh, this is okay. This one's gonna hurt, but okay. So this is still probably going to require pointers. Man, okay, hold on. I'm thinking about this one. Okay, this one is underneath the two-sum approach, right? Or two-pointer approach. Which, okay, I'm listening, but I'm not quite understanding because it's not sorted. Granted, though, I don't have to return the indices. I could just return the values. So I can just sort it. I can just say nums dot sort. Right? Is that what it was? Print nums. Sorts. Is it sort or sorted? Okay, sort. Yeah. So granted, I can just do that. It's not sorted. I'm wondering if I also need to use a dictionary for this one because I'm trying to think. It's not like sliding window, I don't think. Okay, I think I'm having an idea that's popping up. Basically, I'm gonna do like a two-pointer approach, and I'm gonna basically do what we just did on two-sum, and if the target if the sum times -1 exists in the array, and it's not a duplicate element, then oh man, it's gonna be such a pain. What is the time complexity on that, man? We have to go through every single one. But that's that two-pointer. Okay, I'm gonna. Is there an alarm clock on this thing? Here, okay. I'm gonna set like a mental clock for like 10 minutes. At 43, if I'm not anywhere, then I have to give up. That's kind of the way I rule it. So I know I have to use two pointers somewhere, but I'm trying to think like, is it mountain sorted? No, it's random. Mountain sort would be like kind of like a binary search. What does the hints give you? Hint. So we essentially need to find three numbers, x, y, z, such that they add up to the given value. If we fix one of the numbers, say x, we are left with a two-sum problem at hand. Okay, so this is what I wrote. I'm doing it the opposite way. Okay, that's pretty silly. I'm being silly. Alright, dope. Then that's all I need to do. So I'm going to say solution equals that. Equals an empty array. I'm going to ignore that comment. Okay, so I'm going to say for index element and enumerate nums. We're just gonna have to iterate through. So this is gonna be n squared. Yak. I bet you there's a way quick way to do that without using the n squared, but you know, that's how it goes. Okay. So I'm gonna say oh, okay, sorry. Left pointer is equal to 0. Right pointer is equal to length of nums. Nice one. Okay. While left pointer is less than right pointer. No duplicates, or sorry, yeah, no duplicates. That's the great word. While that's the case, do a little quick check. If left pointer is equal to index, then left pointer needs a plus equals 1. Wah! Okay. If right pointer is equal to index, then right pointer needs a minus equal 1. So there's no duplicates. Okay. Now we do two sum. If nums of left pointer plus nums of right pointer plus element is equal to 0, then solution dot append the order matters, doesn't it? So I know left is going to be smaller than right. I know that for a fact. So the index could be, you know, it could be anywhere, really. It could be left, middle, right. So here's my check. I'm going to say if index is less than left pointer, then return here. If index is greater than right pointer, return here, else return here. Okay, we're not return, we're gonna do solution, cringe, solution dot append. This one I probably should have wrote some stuff down. That's okay. I'm not consistent. Okay, so this one's the middle, so this one's gonna be ooh, but I sorted it. No. No. Dude. Wait. I'm coping right now. Hold up. Hold up. Okay. Hold on. I'm coping because it's sorted. It's sorted. It's not in order. Thank the Lord. Okay, get rid of this yak. It's going to equal that. Right pointer and element. And then I'm just going to do this nifty trick called array.sort. Beautiful. And then I'm just going to say solution dot append array. Dude, peek. Let's go. And then return solution. This is probably not going to work. Big doubts. We're throwing some big doubts here. Oh. Oops. JavaScript. I gotta leave the JavaScript alone. Time limit exceeded. Oh, nothing moves. Nothing moves. Oh, crap. Actually, it doesn't matter. I can move either or. Let's move the left one. That time limit. What? Why is that time limit exceeding? Oh! Ah. So silly, man. This is pretty slow. No, I mean, yeah, no, a little bit. Ooh, I'm sorting inside. So not good. Such an ugly look. There's probably a way better way of going about this without sorting. But I can't be bothered. I just love my sorts. Okay. If it's less than 0... Wait. Man, I don't... Ooh. I don't know if this is the right way. I guess we'll find out when I run it. That's so chaotic. Ugh, this is really ugly. Not the right way. I don't think either of these are gonna work. Oh. Ah. Damn. Oh. Oh. No, it's not hashable. Oh. Okay, I have a way of solving this, but it's just that's not the way. I I can make it tuples and then turn it back into an array through a linear path. That's so bad, but I'm gonna do it because I'm desperate right now. Or array to set Python. Can I can I do this? This is like so dumb. Yeah, no, I can't do that. That's fine. Alright, I'm doing this the really bad way. Don't follow my lead, kiddos. This is not how you do it. And this probably won't work. It most likely shouldn't work. Yeah, this is so dumb. Oh, you hate to see it. You hate to see it. This is so bad. Okay, so now I'm gonna make it a set. Solution equals a set solution. Okay, and then now I'm gonna have to turn it back into a list by doing that. And then now I'm gonna have to go back into this, and I'm gonna have to do this again. Oh my goodness, this is so bad. I hate this, and now I'm going to current solution. This I don't think will work. I'm very confident this is gonna have so many errors. It's too trashy, per se. Okay, man. I get it. I understand. I hate myself for this. Please break. Don't work. Please don't work. Please don't. Oh no. Okay, thank God. Give me a duplicate. How the hell did that happen? I thought this directly checks for duplicates. Excuse me. How did that even... That's how. God damn it. I need to watch Necode's video after this because this is really, really horribly done. Aggravatingly so. Yeah. Yeah, no, that's valid. That's so valid. So valid. Yeah. This is a speed test. Checking to see how broken my code is, and it's broken. Alright. So you know what I could do. Hear me out. I could do this. Right. Hold up. Hear me out. And then I can get rid of this. Although, respectfully, I don't know if that is gonna, even after getting rid of this slop, that's... Runtime error? What did I did something? Damn it, man. Still with the fucking duplicates. How are we getting duplicates? We're getting closer, for sure we're getting closer. And it's also, this would be much faster because I'm not like checking the whole thing. But like, why are we getting duplicates here? Seriously, this is... You know, you feel me? Sorry. I'm gonna take a little second out of the way. Okay. So close I could taste it. How do I get rid of this duplicate? How do I get rid of this duplicate? So I'm trying to run this on factorial instead of, you know, permutations. If you get what I'm saying. Oh, I didn't even do this like this check thing because I'm off rip putting left pointer above. Ugh, beautiful, beautiful. I don't even need this, right? Yeah, I shouldn't. I'm not gonna touch it right now though, because first I want to make this work before messing with anything else. Why is this duplicating? You know what? I have to print. I gotta print. What am I gonna print though? What am I gonna print though? I'm gonna print here. I'm gonna print. I'm gonna print array. Yep. But why? Okay. Why did I just do that? I don't need a print array. I know what array is. I'm gonna print this. This is what I'm gonna print. Left pointer, right pointer, and index. Or better yet, index. Because the way I set it up, index is always going to be a lot. Thank the Lord. I don't know why I didn't think about that earlier. I'm going to have to come back to this problem later. Like if I finish it today, which I should. I'm running out of time. 125, 134, 234. Wait. Okay, so even still, this is. Yeah, that hurts. That hurts. Why? What's the fastest way to solve this? Make this not so painful. Yeah. Not for sure. So, I am gonna do what I was doing. I'm gonna just pray that this has less computational time. Because yeah. Yep. This is so silly, man. This is so silly. Solution that add a tuple. Fancy. Tuple up array. Bonjour. And that's it. Yeah, no, and that's it. Then we're good. Right? Is this much cleaner? No, because there's still. It doesn't even matter. It doesn't even matter for the tuple. Let's go. Can I just return solution, or does the set cause an error? Dude, Python is like the most magnificent language known to man. Okay, valid. Valid. That's so valid. I'll let that slide. I'll 100% let that slide. And you know what else? I'm thinking we're gonna break this down because I don't think we're gonna need that no more. And does this have the thing like VS Code does? Oh, thank the Lord it does. All right, run that, run that, run that, run that, run that, and you work. Will it have enough computational time? Oh my days, was I slow. Holy heck. Holy heck, heck, heck. Wow, was that slow. But I did it. I did it. I hated it. I hated that so much. That is so poorly done. But yeah. We're gonna go here and you're gonna sit down and we're gonna watch this together. Because I need to see what the hell I did wrong.
Okay, let's solve LeetCode 15, 3-sum. The sequel to the popular question 2-sum. So before you solve this question, the first thing you should do is make sure that you've solved 2-sum, which is the most popular question on LeetCode, so you've probably solved it, or at least sum 2 integers, as per usual. This array, though, can have duplicates, as we can see in the example, right? 2 negative 1s in this case. Now what we want to do is find 3 numbers of this array, so A, B, and C, and we want them to sum to 0. So in the because then we'll have negative 3 plus 1 plus 2, that's obviously 0. So to our solutions, now we're saying again that, so that means in this case, we're not big O of n, A is equal to nums of I minus 1. That means it's the same value as before. That means we want to continue. We don't want to reuse the same value twice. So we're going to continue to the next iteration of the loop. Next, we're going to use our 2-pointer solution for the remaining portion of the array to basically solve 2-sum. So we'll have left and right pointers. Left will initially be I plus 1. We want to use each number in the int array as a possible first value. So I will iterate through the index and the value. And remember, we don't want to reuse the same value in the same position twice. So if I is greater than 0, meaning this isn't the first value in the int array, and this value A is equal to nums of I minus 1, that means it's the same value as before. That means we want to continue. We don't want to reuse the same value twice. So we're going to continue to the next iteration of the loop. Next, we're going to use our 2-pointer solution for the remaining portion of the array to basically solve 2-sum. So we'll have left and right pointers. Left will initially be I plus 1. Right will be the end of the list. Length minus 1. Left and right can't be equal, so we're going to say left is less than right. Now we're going to actually compute the sum. So we'll say our 3-sum is A plus nums of left plus nums of right. So if the sum is too great, remember, if it's greater than 0, which is what we're looking for, then we need to decrease it, in which case we would say our right pointer needs to be decremented. On the other hand, if it's too small, we need to make the sum bigger. If only I could type today. If it's too small, we need to make it bigger, so shift our left pointer to the right. The last case is if this is equal to 0, so of course we have to add it to our result. So to our result, we're going to append all 3 numbers. So the numbers are A, nums of left, and nums of right. Now, of course, we got to update our pointers, but how do we update it? There's a lot of ways you can do it, but I'm going to show you the way that you can do it with writing the minimal amount of code. So let me just write a comment to show you a little bit. What if we had the 2-sum, basically for these left and right, and we were at negative 2, so negative 2, 0, 0, 2, and 2. What if our left pointer was here and our right pointer was here? In that case, we found a solution, let's say, right? Then we'd want to update our left pointer, right? So then our left pointer gets to negative 2 again. But that's the same one as before. So in that case, we want to update it one more time to get it over here, right? Now in that case, now our sum is going to be too big because we're going to be at 0 plus 2, so that's greater than 0. So then our loop is going to execute saying that this is too big, and we're going to shift the right pointer to the left. But notice how that right value is now the same as it previously was too. But that's okay because our sum is going to evaluate as too big, so our right pointer is going to be shifted again. Notice how each value is only going to have one corresponding value that it can sum equal to the target, which is 0. So we only have to update one pointer, and our 2 conditions up here will update the other pointer by itself. We don't even have to worry about it.
Wait.
as 2 big, so our right pointer is how that row plus 2, same one as before. So in that case, we want to update it one more time to get it over here, right? Now in that case, now our sum is going to be too big because we're going to be at 0 plus 2, so that's greater than 0. So then our loop is going to execute saying that this is too big, and we're going to shift the right pointer to the left. But notice how that right value is now the same as it previously was too, but that's okay because our sum is going to evaluate as too big, so our right pointer is going to be shifted again. Notice how each value is only going to have one corresponding value that it can sum equal to the target, which is 0. So we only have to update one pointer, and our 2 conditions up here will update the other pointer by itself. We don't even have to worry about it. So in this case, we're only going to shift our left pointer because we don't want to have the same sum. We're going to have to use a loop. So in this case, if nums of left is equal to nums of left minus 1, that means it's the same value, so we have to keep shifting our pointer. But remember, we don't want our left pointer to ever pass the right pointer, so we're going to add that to the condition. So this is all we need to do. Now I believe, unless I've made another stupid bug, we should be able to just return our result and pass the problem with the most optimized solution. Which I'm praying that this works on the first try. Let's see. We passed the test case, the first test case. They really want you to buy LeetCode Premium. This is okay, so it did pass. Usually I have some stupid bugs where I mess up a condition, but okay, so we passed it. This is pretty.
I'm thinking about this continuing, this ignoring. It's pretty smart. I didn't think about that. So, mine's a little bit different, but let's try. Oh. Wait. Is that gonna do something for me? Hold up. If index is greater than 0 and element is equal to nums of index minus 1. Continue. Okay. Oh my days, that works. And it's much cleaner. Nope, wait. That didn't work. That did not work. Why did that not work? Is it because I need this? And you need... Ha! So... you have to keep that base condition. And, oh yeah, and it's the same. And left pointer is equal to... No. Yes? No. Num of left pointer. Nums of left pointer is equal to I don't... Huh. Much faster too. Okay.
Exactly why this eliminates...
I probably need to listen to like how he algorithmically explains the concept so that way I can like truly wrap my head around it. Alright. Well, that was only 2 today. 2 mediums. Yeah. That was it today. Maybe I'll do more another day, but I gotta get to bed. And I gotta eat dinner. Kind of had a protein shake. Okay. Thank you for watching. And I'll see you tomorrow.